I could not do that.
Okay, let's talk about this. What do you remember?
Nothing.
What's our strategy here? Somebody help me out. Somebody raise your hand and help me out. What do we do for
Figure
problems
out
like this?
Don't you distribute into the.
No, I can't. I don't distribute.
Oh, okay.
Add 2 to the other side.
Okay, so suggestion is add 2 and then what else?
Divide by 4.
Perfect. Okay, why are we doing that? Adding 2, dividing by 4. Why?
And then you just put negative 2 minus x.
Okay. Our goal is, our first goal is always to isolate the absolute value, right? Remember this stuff from before?
No.
You may not, and this actually illustrates a really important point. The reason you don't understand this is because the way you learned it before, you just learned a series of steps. And when you learn a series of steps, you just forget them because that's not a very powerful thing. It's like learning facts. If you learn individual facts, you forget them. But if you learn ideas, instead of facts, you remember them because they're comprehensive. They engage lots of your brain. So we're going to look at this again today in a little different way than we did during our review. We're going to look at this in a new way, an Algebra 2 way, which will help you this really stick. So we're going to isolate the absolute value first of all, right? So we want to then, and one of the things we're going to do to help us do that is we're going to try a technique that you do in higher level math classes. It's called a U substitution. It's a really fancy way of saying we're just going to block out all the stuff inside of the absolute value, and we're just going to think of it as being something simple. Call it U, okay? And then our goal is we want to isolate the absolute value of U. And you already told me the correct steps. The correct steps are you add 2 to both sides, right? So I end up with 40 on the right side. I divide both sides by 4, so I end up with the absolute value of U equals 10. And then what? This is the part where I think people start to maybe forget what to do.
Is that what you popped a bubble or something like that?
Yeah, okay, we talked about it as a bubble, I think. And now instead of a bubble, we're going to call it U. Okay, U represents the bubble. Let's think of it this way. Let's look at an example that I think will really illustrate this. So if we, not that, that's physics. You can ignore that. Oh, that's the pirate puzzler. Hang on, where is this stuff? It's right here. Okay, so here's what I want to do with this. Okay, we're going to take, actually I want to do one other one first. Forgot about this. I want to do, where'd it go? This guy. Okay, remember this stuff. All right, so remember problems like this that I gave you in Unit 1. I'm just going to do a quick review. What if I gave you the problem? I said, using graphing technology, I want you to solve the equation negative 1/2 x squared minus 8x minus 29 equals negative 6. What would we do using graphing technology? Remember how we'll do this all year. We'll take a test on this. The graphing technology tests should just get easier throughout the year because it's the same stuff over and over again. Right? All we ever do with this is we're going to graph what's on the left side of the equation as one graph. We're going to graph what's on the right side as another graph and see where they intersect, right? So we're just going to set y equal to whatever's on the left side. Well, there's my y equals negative 1/2 x squared minus 8x minus 29. That's the red graph. It's a parabola, right? It's quadratic, so it's an upside down parabola. We graph y equals negative 6. That's what's on the right side. That's just a horizontal line at negative 6. And then all I have to do is look for the intersections of those two graphs, and those will be my solutions, right? So what are they then? Well, the graphs intersect there and there. So what are the solutions to this? If you look at this equation, this is an equation with x's in it. So I'm looking for x's. What are the x values that are going to be solutions of this equation that'll make it true?
Negative 12.2 and negative 3.8.
There you go. There's one. Negative 12.243 to 3 places and negative 3.757 to 3 places. Those are the solutions, right? That's a graphical method that's always going to work, right? We can always solve any equation by graphing the left side, graphing the right side, setting the two equal to each other means finding where they intersect, okay? So now let's look at an example with an absolute value function. Now that we've done a lot of work with absolute value functions, you know what they look like. This will be really simple. Okay, so this time let's take the equation, let's do the equation absolute value of u equals a. And a is just going to be some number. Okay? Let's see what these look like. Well, the absolute value of u, there's y equals the absolute value of u, right? Just an absolute value graph. What are the characteristics of that parent graph? We used it a ton. It's a V with the vertex where?
0, 0.
0, 0. For this parent graph, if I go over by 1, I would go up by 1. If I go over by 10, I go up by
10.
If I go over by 1,000, I go up by
1,000.
1,000. Right, the slope is just 1 of that leg of the V, isn't it? And this one's -1, so if I go back by 5, I go up by 5, right? Okay, so then this is what the red part of our graph looks like. If I graph y equals the absolute value of u, we get that answer. Now let's graph y equals a. Well, if I graph y equals a, I get this, right? So let's zoom out a little bit. And I can see that my intersections are going to be there and there, right? Okay. What are the coordinates going to be of those points of intersection? So that point right there and that point right there. Now, I know that this looks like a is equal to 10 here, but pretend it's not. It really doesn't need to be 10. It could be anything. We're just going to call it a, right? So if the equation of this line, this blue line, is y equals a, then how high is that point?
10.
Well, not 10, a, right? Regardless of what a is. I mean, a just happens to be 10 now, but let's pretend we don't even know what it is, right? So would you agree that the y-coordinate of this point then is going to be a?
Yeah.
Right? Because that's the height of this line, right? What's the y-coordinate of this point going to be?
A.
A. Okay, what's the x-coordinate of this one going to be?
0.
Now think about an absolute value graph. If I'm going up by a, I must be going over by a, right? So this distance right here is a, and that distance is a. So it's going to be a and a, right? What about over here?
Negative.
Negative a and a, right?
Yep.
Okay, so if I want to know what the solutions are then, all I've got to do is I've just got to look for the places, right? I've just got to look for the places, the x values where that happened. Okay. So here's my a value, right? That's x equals a. So one solution is down here at a. The other one is down here, right, at negative a. That's it. Those are the two solutions, right? It's always going to be that way. Here's a little summary, what we just did. Okay, that makes sense? So the absolute value of u equals a when we end up at these 2 points. And so that's just where u equals negative a or u equals a, right?
It says negative.
Yeah, it says negative A.
Oh, whoops, that should be a. Okay. Okay, make sense? Okay, so whenever we start off with something like this, the absolute value of u equals a, the solutions are going to be either u equals negative a or u equals a, and the way you remember it is from this picture, right? Because that's going to be where this horizontal line intersects the v. Okay, make sense? Okay, so try one of these then. Oh, well, let's go back to our original one. So then, what's going to happen here? So for this one, we left off right here, right? We left off right there. Where do we go from there? If we have the absolute value of u equals 10, well, now we know. The absolute value of u equals 10, the solutions are going to be either u equals negative 10 or u equals positive 10, right? That makes sense? And so finally, now notice that we haven't messed with anything inside the absolute values up until this point, right? But now, finally at this point, we can go back and say, okay, well, what's behind that u? You know, what's behind the u is actually a 2x minus 6. So I'm left with these two equations that are very easy to solve that will tell me the values of x then, right? So what are the steps to solve for x there?
Plus
Add
6.
six.
Add 6.
And divide by -2.
Okay. So add 6, so we get negative 2x equals negative 4, right? Divide by negative 2 and get
Positive.
x equals 2, or over here if I add 6, I get negative 2x equals 16, so x equals,
-8.
that's it, right?
I did it right.
No big deal. Okay, so real quick, you guys try that one. Okay, and think what you're going to do here, right? All I'm going to do with this is, right away, I've already got an isolated, actually skip that one. Do this one. Do that one. Do that one. That's a little better. Okay, so we're going to isolate the absolute value first, right?
Yeah.
We don't care what, at this point, we don't care what's behind the absolute value. We're just going to do that. Call it a u. Okay? You want to write it down first? There you go. You can write it down. Okay? All right, go.
34. 34?
What's on the inside of it?
Hmm?
What's on the inside?
Inside is 2x minus 20. I'll leave it like that. How's that?
That's what I thought. But if we get it wrong, then I don't know what it is. That's what I thought. I don't think it has to either or.
Say it again. I don't know. Honestly, don't know.
Because I don't think.
I've done it yet. It seemed like it was going to turn out to not be decimals. But, oh, man. Oh, there you go. Yeah, that's it. Yep, that's it. Okay, there you go.
27 negative 7.
Yeah.
Okay, so let's go through this one. Yeah, no big deal, right? So what we got to do first? We got to isolate the absolute value, right? So we're going to isolate the absolute value, and we're just going to call, whoops, we're going to call this u. Okay, and so then we subtract 11. So that gives us 2 times the absolute value of u equals what? 68? Divide by 2 and get absolute value of u equals 34. Now what?
Then you have to open up the U and then you have to.
Not quite.
What?
Not quite.
Oh, that's.
Josh,
Sorry.
what do we do next here?
You do that other way.
Okay, we got to get rid of the absolute value, right? We know the absolute value of u, that's the v, right?
Negative u.
The v is equal to a y value, Willie, of 34, right? When u is equal to 34 or negative 34, right? So those, we're going to trade for our two equations. Either u has to equal negative 34 or u has to equal positive 34. Now finally, now that we've got this broken apart, now finally we'll look behind and see, well, what is u equal to in terms of x? And now we'll solve in terms of x. So then we just get the simple equations, 2x, whoops, 2x minus 20 equals negative 34, or 2x minus 20 equals positive 34. You guys, that's no big deal. You can do that, right?
27 negative 7.
27 and negative 7, sounds good.
That boys and girls.
Okay, so what about this one? Let's try this one real quick.
Oh,
Okay.
math way. Oh, what the?
Yeah. No, math, bro.
Okay, hey, listen, right now I feel like people are getting off task. I should see everybody in their desks facing this way, notebooks out, phones away, right? Okay, so same as before, right? We're going to go ahead and we're not going to even worry about what u is yet. But we don't even really care. Eventually we'll find out, but for now we don't even care. We got to isolate the absolute value of u, right? So I'm going to get 0. I'm going to add 11 to both sides, and I'm going to get 2 times the absolute value of u equals 0. If I divide by 2, I get 0, yeah. 0 divided by 2 is 0. So I get the absolute value of u equals 0.
Negative 2.
Okay, sure. Hang on.
No, it's negative 2. Negative 2. Already got it.
Okay, so if we pull this up, then what's inside the absolute values is when we set, I guess the next step is kind of weird. We have then u equals 0 or u equals negative 0. Well, what's negative 0?
0.
Just 0. So we get the single equation, u equals 0. U is 3x plus 6. So if I isolate x, what do I get?
0.
Still 0.
2.
Well,
6.
hang on, I subtract 6. So 3x equals negative 6. Divide by 3.
Negative 2.
X equals negative 2. How could we check to see if it works?
Plug x in for
Plug it
negative
in?
2.
So if I plug negative 2 in, look what happens. I get 3 times negative 2 is negative 6 plus 6 is 0. What's the absolute value of 0?
0.
Times 2 is 0. So 0 minus 11 equals negative 11. True, it worked. Okay, what's going on here though?
That's weird.
If we go, it's a little weird. If we go back to our picture, not this one, we go back to this guy, what's the difference here? Okay, so we ended up with, instead of u, the absolute value of u equaling a number, we got the absolute value of u equals 0. Well, let's see what that looks like. If I slide the value of u, not u, the absolute value of u equals 0. So if I slide the value of a, right, because here we've got the absolute value of u equals a. If I slide the value of a back to 0, look what happens. What happened to the horizontal line that we're intersecting?
It moves down to 0.
It's just right on the x-axis, and so it only intersects the v at its vertex, right?
0.
Does that make sense? And so then we get the single solution here. Look at that. We only get 1 point right there instead of 2. And the solution is just u equals 0, which is what we got, isn't it?
Yeah.
Right? If we go back to the work we just did, that's what we got. We got the answer u equals 0, but when I made my substitution, that worked out to be a specific x value. When I substituted what really u is, which is 3x plus 6, right? Okay, what if, hypothetically, what if we had gotten, and really concentrate on, I'm not going to do a separate example, so you got to really focus on this so you can see what's going on. What if instead we had gotten something like, let's say after we did the work, after we isolated the absolute value, let's just say we had gotten something like the absolute value of 2x minus 3 equals negative 3. What do you think is going to happen there? When would the absolute value of u equal negative 3?
Never.
Never. That's right. Look at our picture. If I make a negative, so I'm setting the absolute value of u, the red v, equal to a number that's negative, like negative 3, does the blue line ever intersect the v?
No.
No. So there's no solutions, right? Does that make sense? So then, and honestly, we don't even really need the picture to tell us that. I mean, think about an absolute value function, what it does. What's the absolute value of negative 3?
3.
3. What's the absolute value of 0?
0.
So do you understand that no matter what number I end up putting into my absolute value bars, I'm never going to get back a negative answer, am I? I'm only going to get back 0 or a positive answer. So this could never happen. Right away we could look at this and say, nonsense. The absolute value could never, there's no value of x we could ever plug in there that's going to make the absolute value of something equal a negative value. Right? That's got no solution. Okay? All right, so next issue then. How about something like this? I am. That's how serious I am about math. Okay, so this time let's try something like the absolute value of u is greater than, actually is less than or equal to, let's do, less than or equal to a. Okay, so let's see what that looks like. So now, there's my absolute value function, right? But what's going to happen here? If I want all the values where u is, absolute value of u is less than or equal to a, I'm not really looking for just the intersection of the horizontal line. What's it going to look like if I graph all the places where y is less than or equal to a? If I graph y equals a, I just get a horizontal line at y equals a, right? But if I'm graphing every place where y, all the places on the xy plane where y is less than or equal to a, what's that going to look like?
On the x-axis and below.
Okay, it's going to look, well, close. It's going to look like that, isn't it? Right? So if this is a in this case is 5, right?
Okay, yeah.
Does that make sense? So it's going to be, there's the borderline, y equals 5. But then if we want all the values that are equal to 5 or the y values that are less than 5, that's going to be all other y values below that line, right? So for example, if I were to pick a point like right there, for example, wherever I just hit. So there's a point, right? That point is in the blue region, so guaranteed the y component of that point is less than or equal to 5, isn't it?
Yeah.
Not that guy right there, though. His y value is bigger than 5, so he's not in the shaded region, right? Okay, so then now, what does this overlap look like here? We want to find the intersection of the red V and the blue half plane, right? So every place, you can almost think of it like this is the water line, and if an ant were walking down this V and up the other side, where is he going to be? At the water's surface or underwater?
Negative 5 and 5.
Yeah, and once again, don't think of it as a 5, think of it as an A. So if the coordinates here of this point,
Negative 8.
if those coordinates are, you told me before, those are, why this thing does this, it gets real. Sometimes it just lags behind, I don't know what it's doing.
No, stop hacking. I'll rate it.
That's not it, I think there's, I think my computer's like doing something in the background, so it's really slow. We have such great technology.
Just restart the computer. You'll be fine.
Restart it.
Hold on.
Put it down.
It probably wait a
You
second.
put it down once.
There, it's working now. Okay, so negative A and A was that point you told me, and this point was at A, right? And so then we know that as the ant's walking down this slope, This is the place right here where he first enters the water, right? So that's gonna be part of the solution, right? He's underwater this whole part, and finally right here is where he's gonna leave the water. But he's at the water level or underneath the water in all those places, right?
Yeah.
Everybody agree? Yep. Okay, so then whenever we end up with a situation like this, where we've got the absolute value of u is less than or equal to a, this is what the solution looks like. And how do we say that is an inequality? Isn't that just u is greater than or equal to negative a and less than or equal to positive a? Wasn't that the way we said an interval that has boundaries on both ends? Right? That's a compound and inequality, isn't it? Right? So these always go together. You can always associate this. If we ever get a situation where we've got the absolute value of u is less than or equal to a, this is the trade that we're going to make every time. And the way, how do we remember it? Because of this picture, right? This is the picture that we use. We have a V, and then we have a horizontal line and everything below the line, which is going to correspond to just a certain part of the V, right? So then how about a problem like this? Oops, yeah, like that. Try that. What are you going to do? Okay, we can ignore everything inside the absolute value for now, right? Call it u. What are the steps going to be we're going to go through?
Same as the other one, right?
Pretty much, yeah. What are we going to do first?
Plus 1.
Add 1. We're going to isolate the absolute values. So we add 1, and we get 2 times the absolute value of u is less than 6, right?
Yep.
Now what?
Divide by 2.
Divide by 2. If I divide by a positive, I don't have to flip the direction of the inequality, right? Only if I divide or multiply by a negative. So I end up with absolute value of u is less than 3. Now what's the trade I make there? What's my trade? If we go back and look, there's the trade I make, right? If the absolute value of u is less than or equal to the horizontal line, then those are only going to be the x values between negative a and positive a, right? So here we don't have an a in our problem. We have u is less than 3 instead of a. So what's my trade going to be?
3 is less than 2.
So u is greater than, u is greater than what? No. Negative 3 and less than positive 3, right? That's the pattern, right? And it's just, there's the pattern, right? There's the pattern. If u is less than or equal to a, then u is greater than or equal to negative a. That was a 3 for us, right? And less than or equal to positive a. That was a 3. So those became 3s, right? Okay. Now finally we can say, okay, well we got this thing solved as 2 inequalities. You know, it's a double inequality, a compound inequality. And so now finally we can look behind inside the absolute value and what's back there? Well, 3x plus 9. So we actually end up with the compound inequality, negative 3 is less than 3x plus 9, and 3x plus 9 is less than positive 3, right?
Yep.
So it's trapped between those values. What are the steps to solve for x? Or something like that? Do you remember how to deal with that?
9.
What do I do?
Minus 9.
Okay, I'm gonna have to isolate x, but in order to isolate x, I've got to subtract 9 and divide by 3 to all 3 parts of this inequality, right? So we'll subtract 9, and that gives me negative 12, 3x, and negative 6, right? Now what? Now what?
Divide by 3.
Divide by 3, good. So that gives me an x in the middle, and then over here I'm gonna get, what, -4, and over here I get -2?
Yep.
Up and down. Yep, so that's my answer. Okay? No big deal, right? Okay, last issue then. Last possible thing that could happen is, what if we end up with something like, oh, yeah.
Miss Watts.
There we go. Oh, well, okay, what about one like that? Okay, so here's the last situation. I guess I didn't make a slide of this. That's all right. I'll make it now. Okay, what about this guy? What if we're going to do this time absolute value of u, so there's our v, right? Absolute value of u is greater than a. Okay, so here's absolute value of u. What's it going to look like if we graph the region where y is greater than a instead of less than?
All the way up.
Ah, okay, it's going to be from the line up, right? So like that. Okay, that makes sense? Those are all the y values greater than a. So notice we have a dashed boundary line this time. We're not including the boundary line, just the half plane above it, right? So this time we want to know where is the intersection of the two regions. Where's the blue part overlapping with the red V? Well, everybody see it's going to be, here's going to be one of them's right there, right? So that's going to be at -a, a. This one's at positive a. So the x values are -a and positive a, but then I'm only going to take the parts to the left of this point, right? And oh, by the way, should that, I made a mistake there. I made that solid. Should it be solid?
No.
No, it shouldn't be. Shouldn't be solid. Should be open, shouldn't it? This one's open. How come this one's not closed?
Because it's not equal to it.
Okay, there's no equal to there. Good. And then we're only going to shade the regions off to the sides, right? Okay, so then what's the moral of that story? If we start off with something like this, what are we going to end up with? We're going to end up with either u is less than -a, right? Or u is greater than positive a.
Yeah.
Okay? So that's always what we get if we have an absolute value of u is greater than a number. Okay? So then do this for me. If you can do this, you're set. So what's our strategy going to be here?
+6.
Okay, good. We're going to add 6 to both sides. And that gives me the absolute value of u is greater than 24. So what's the trade I make? If the absolute value of u is greater than a number,
It's -24.
okay, good. Then u is either less than -24 or u is greater than +24. And now that we've separated into the two equations, we followed the rules where we can't mess around inside the absolute value until we get here. Now we can substitute what's actually inside. And we end up with -3x plus 21 is less than -24, or -3x plus 21 is greater than +24. What are going to be the two steps to get this x by itself?
-21.
Subtract 21, good. So -3x is less than -45. Now what?
Divide by -3.
Divide by -3. Patrick, what's that going to give me? What?
That's a weird one. That's weird. 15.
Then, okay, 15, good. So
job,
x is
Pat.
less than 15, or what about over here? If I subtract 21, I get negative 3x is greater than 3, right? So if I divide by negative 3, what do I get?
Negative 1.
Okay, x is greater than negative 1. So those are my solutions. Either x is less than 15, or x is greater than negative 1. Oh, you know what I didn't do? Whoops, what did I forget to do? Something important.
You forgot to do minus 20 on the floor, right?
I forgot to flip it. Very good. What did I do?
Flip the sign.
Everybody get that? How come I have to flip the sign here?
You divided by a negative.
Ah, very good. I divided by a negative, didn't I? So that means I have to flip the sign around. So my solution is x is greater than 15 or x is less than negative 1, right? Wow, that's a lot of stuff to know, okay? You got it? Yeah, I'll put the assignments up. Once again, if you do the assignments, you can use Monday to retest. Okay?
You say, like, the scores in your review reflect on what?
On 2 missing assignments.
Sweet.
Yeah.